Okay guys, so today is all about story problems, max and min problems. So it's a little bit more difficult, but I'll try and go through it slowly. First example, we have an open top box with a square base to be constructed from sheet metal that has a surface area of 200 centimeters squared. Express the volume of the box as a function of its base. So the first thing I did is I drew a picture of the box. It had a square base, so that's width and width because it's square. And the height I don't know. So I needed two formulas. One, I needed a volume formula. So volume is length times width times height, but it's really W times H or W squared H, okay? I needed a surface area formula. The surface area is the four sides plus the bottom. So the four sides are all rectangles, W by H, so I got four WH's, and the bottom's a square, W squared, okay? Now, I know this one is 200, so I put my 200 there. What I have is two equations. I want to make the volume with respect to H. So I don't want volume with respect to width. I don't want an H. So I want to get rid of the H and everything all in terms of W. So what I did is I went to my other equation, and I want to solve for H so I can substitute. So to solve for H, I went minus W squared from both sides, divided by 4W, and I get an expression for H. So then I put this expression for H into my height, and now I have volume with respect to width. Now I simplified it quite a bit and got it all the way down to here, okay? And then I needed to graph this. So you can't use your calculus. Sorry, no calculus on Desmos. No Desmos, but we can use our graphics calculus. So I did that. I put in my graphics calculator. So I went 50x, not W, I got to use x, minus 1/4 or 0.25 x cubed. And before I graph it, I'm thinking about my window. I think it's much bigger than this. I can go 0 because I can't have a 0 width. I don't know. I'm going to try 25. And then I'm going to think about how big this box is. If this is a 200, I might try 500. So I'm just trying around my window. So I change my window. I graph it. Oh, good. That's a pretty good window. I want the maximum. So I went to second calculate. I want to calculate my maximum. Left bound, so I'm trying to tell the calculator where to look. So I go to the left hand side of the maximum, blinking, enter, locks it in. Right hand side of it, it's blinking, enter, locks it in. Now the calculator's going to find it for me. So it's about an 8.16 and a 272 is what I got from the calculator. Okay, so that means the width is 8.16 and the volume, because it's V, is about 272. Now if I want the height, I took this 8.6, which is my width, and I plugged it into the height formula, and I wound up getting about 4.1. Okay, now if this goes too fast for you, slow it down, pause it, think about it. Okay, all right, now turn the page. Now the second problem. Okay, you've got a boat that's coming into this point, they're cruising along, and you've got a horse that's going out. As the two move on, there's a certain point where the two of them are closest together. And we want to find that distance because if they keep going, then they're further and further apart, okay? So at what point, at what time are they close? So what I see is a right triangle. And I know in a right triangle Pythagorean theorem, which is going to illustrate their lengths, a squared plus b squared equals c squared, okay? Now, before I do too much, then the length of this, I know that the distance of this is in terms of rate. So the horse rides at a rate of 12t. That's its distance. The boat starts at 25 and its distance gets smaller. Boat starts at 25 and gets smaller, so it gets smaller at a rate of 25 minus 16t. Okay, so then I'll call that d, the distance closest to them. Okay, so then I just set up a squared plus b squared equals c squared, horse squared, that squared, boat squared equals d squared, and I solve for d squared, so I square root of both sides. I get distance with respect to time equals a parentheses 12t squared plus 25 minus 16t quantity squared. Now, I have to graph this. I'm going to go back to my y equals now. Okay, I'm going to go y equals, I'm going to go square root of parentheses 12. I got to use x. I have to use x quantity squared plus parentheses 25 minus 16. I have to use x quantity squared, okay? Now, window. Well, this time is, x is our time. There's no way 25 hours. I'm thinking 2 hours at the most that they would be closest at the most. And then this is 500. Well, I can put that 0, right? This is 500. I know the greatest they can be is 25, so I'll make that 25. It's going to be less than that, okay? So I fix my window to make it work. I graph it, and I'm looking for the minimum. That window seemed to work. So again, I want the minimum, so I'm going to go second, calculate my minimum. It's right about there. I'm going to go left bound, right, but I just want to go to the right-hand side of it so I can tell the calculator where to look right there. And I get an answer about 0.9999 or 1. So it turns out to be a point of 1:15. So that's in terms of time, hours. So after 1 hour, which is 3 o'clock, they will be closest at a distance of 15 kilometers away. Okay? So if you have questions, come see me. You can pause the video and look at it later. But we're going to keep doing these.